Okay, so today, Justin Franz and I will teach you how to answer this question. How many kilograms of iron can be produced by the reaction of 7 kilograms of iron 2 oxide and 3 kilograms of CO2? So, the equation for the reduction of iron ore in a blast furnace is given below. So it says that iron 2 oxide plus 3 carbon monoxides go to 2 iron plus 3 carbon dioxide. That's our equation. It's important to look at your equation to find multiple ratios. So now we start off with what we know. The question gives us the amount of iron 2 oxide we have, and it also gives us the amount of carbon monoxide. These will be used in our first two equations. Now, we need to find the amount of moles are in 7,000 grams of iron 2 oxide. So we do that by using the conversion factor 1 mole over 159.7 grams, which is the molar mass of 1 iron 2 oxide. And then we also need to convert that to our ratio up in here, our mole ratio in our equation, which iron 2 oxide goes to iron. There's 1 iron 2 oxide for every 2 irons. That's why we do a 2/1 ratio. We calculated that to equal 87.664 moles of iron. Now we go with our second problem. We have 3,000 grams of carbon monoxide. We need to get how many moles is that, so we divide that by 28.01 grams.
Which is the molar mass of carbon monoxide.
Thank you, Justin. And then we need to look at our equation up here and see what our multimole ratio for iron and carbon monoxide is. So we see 3 carbon monoxides to 2 iron. The reason why we have iron on top is because we're trying to get to iron and cancel out the carbon monoxide. These two cancel, grams cancel, you're left with moles of iron equals out to 71.4 moles of iron.
So doing these two calculations calculates our limiting reactant for our reaction. And we can see that our limiting reactant is the carbon monoxide.
Thank you, Justin.
So then we take the amount of the amount of iron that can be produced with the amount of carbon monoxide that we have, and we multiply that by
55.85 grams, which is 1 mole of iron, and that equals out 3,987.7 grams of iron. That's how much we have. We need to convert to kilograms because, as we see in our question, it asks for kilograms. So we divide by 1,000 to get 3.988 kilograms of iron. Now, what does that tell us, Justin?
That tells us the amount of iron that can be produced by our reaction.
Thank you. Delete the video.
Yeah. So, our second question is how many kilograms of the excess reagent remains after the reaction has ceased? And we still have our equation from before. So we take our limiting reactant amount, which is 71.403 moles of iron. We divide it by 2 because
you have 2 moles of iron for every 1 mole of iron 2 oxide. So to go from iron to iron 2 oxide, you need to divide by 2.
So then we end up with 35.7 moles of diatomic iron. Then we can take this 35.7 moles and multiply it by the molar mass of iron 2 oxide, and then that gives us 5,701.29 grams of iron oxide. And then we take that amount from our original amount of iron, which is 7,000 grams, and we get 1.2987 kilograms of leftover iron oxide.
Thank you. This has been Justin and Sam reporting for chemistry.com.